Okay, a good evening to you all. So welcome to this recording. So basically, we are going to look at mathematics, but basically we are going to handle the part of trigonometry. But we go any further, I want to introduce my group members and me myself, send out the mic. Then I have Sabat. I also have Namaiga Mary Francis. So this is the team that we are going to use to represent this topic. So in a brief, we are going to look at trigonometry, as I stated earlier. So trigonometry is a branch of mathematics. That is the first thing. So I think we all know that, and we've done some research back. We have seen trigonometry or some trigonometric functions. So if maybe someone can read for us the definition of trigonometry. Maria, can you read for us the definition of trigonometry?
Trigonometry is a branch of mathematics that studies the relationships between angles and sides of triangles.
Okay, that is trigonometry. So trigonometry encompasses of quite a number of some subtopics, and we have the keywords. The key subtopics, we have the cosine, we have the sine, and also we have the tangent. So those, in brief, are the major ones. So that is trigonometry. So it includes the sine, the cosine, and then the tangent. However, it has some other key terms where we have angles, then we have hypotenuse, we have the unity circle, and then we have the radians. So we are going to look at one by one, and we are going to go deep and see how these terms or these keywords have in general. So we can proceed, and we have, before I proceed, so in slide number 2, I have certain video. It is an introduction to trigonometry. So make sure that by the end of the video, it is kind of quite long, but I'm going to play it for some minutes, and then thereafter you will tell me what you will have got in the video. So in brief, this is the video. Let me start playing it. So I think you can hear the
Have you ever
audio.
heard of the expression SOHCAHTOA?
Yes.
What do you think this expression means? In this
Okay,
lesson, we're going to focus
you
on
go through the
learning triangle
video as we
trigonometry.
see what
Let's
it
say
has.
if this is the angle theta. Now there's three sides of this triangle that you need to be familiar with. Opposite to theta, this is the opposite side. And next to the angle theta is the adjacent side. And across the box, or the right angle of the triangle, which is the hypotenuse. That's the longer side of the triangle. Now, if you recall, this is A, B, and C.
Yes.
The Pythagorean theorem applies to right triangles. A squared plus B squared is equal to C squared. But we're not going to focus on that too much, but just be familiar with that equation. Now let's talk about the 6 trig functions in terms of sine, cosine, tangent, opposite, adjacent, hypotenuse. Sine theta, according to SOHCAHTOA, S is for sine, O is for opposite, H is for hypotenuse. Sine theta is equal to the opposite side divided by the hypotenuse. Cosine theta is equal to the adjacent side divided by the hypotenuse. Ca is for cosine is adjacent over hypotenuse. And tangent theta, TOA, is equal to the opposite side divided by the adjacent side. So that's the tangent ratio. It's opposite over adjacent. Now we know that cosecant is 1 over sine. So cosecant is basically hypotenuse divided by the opposite side. You just need to flip this particular fraction. Secant is the reciprocal of cosine. So secant is going to be hypotenuse divided by the adjacent side. Cotangent is the reciprocal of tangent. So if tangent is opposite over adjacent, cotangent is adjacent divided by the opposite side. Now let's say if we're given a right triangle and we have the value of 2 sides. Let's say this is 3 and this is 4. And here's the angle theta. Find the missing side of this right triangle and then find the values of all 6 trigonometric functions: sine, cosine, tangent, secant, cosecant, cotangent. Now to find the missing side, we need to use the Pythagorean theorem. A squared plus B squared is equal to C squared. So A is 3, B is 4. And we got to find the missing side, C, which is the hypotenuse. 3 squared is 9, 4 squared is 16. 9 plus 16 is 25. And if you take the square root of both sides, you can see that the hypotenuse is 5. Now it turns out that there are some special numbers. There's the 3, 4, 5 right triangle, the 5, 12, 13 right triangle, the 8, 15, 17 right triangle, and the 7, 24, 25 right triangle. And any whole number ratios or multiples of these numbers will also work. For example, if we multiply this by 2, we'll get 6, 8, 10. That can also work. Or if you multiply it by 3, you get the 9, 12, 15 triangle. If you multiply this one by 2, you get the 10, 24, 26 triangle. Those are also special triplets. They work with any right triangle. Now some other numbers that are less common but you might see are the 9, 40, 41 triangle and the 11, 60, 61. So if you see some of these numbers, you can find the missing side quickly if you know them. So now let's finish this problem. So what is the value of sine theta? So according to SOHCAHTOA, we know that sine theta is equal to the opposite side divided by the adjacent side in the part SO, S-O-H. Opposite to theta is 4. And the hypotenuse is 5. So therefore sine theta is going to be 4 divided by 5. Now cosine theta is equal to the adjacent side divided by the hypotenuse. So we said 4 is the opposite side, 5 is the hypotenuse, and 3 is the adjacent side. So in this case, it's going to be 3 divided by 5. So that's the value of cosine. Now let's find the value of tangent. Tangent theta, according to TOA, is equal to the opposite side divided by the adjacent side. So that's going to be 4 divided by 3. So that's the value of tangent. Now once we have these 3, we can easily find the other 3. To find cosecant, it's 1 over sine, so just flip this fraction. It's going to be 5 over 4. And secant is the reciprocal of cosine, so flip this fraction. Secant is going to be 5 over 3. Cotangent is the reciprocal of tangent, So if tangent is 4 over 3, cotangent is going to be 3 over 4. And that's how you could find the value of the 6 trigonometric functions. Let's try another problem. So let's say this is theta again, and this side is 8, and this side is 17. Find the missing side, and then use the completed triangle to find the value of the 6 trigonometric functions. So go ahead and pause the video and work on this problem. So first, we need to know that this is the 8, 15, 17 triangle. If you ever forget, you can fall back to this equation. So A is 8, we're looking for the missing side B, and the hypotenuse is 17. 8 squared is 64, and 17 squared is 289. 289 minus 64 is 225. And we need to take the square root of both sides, and the square root of 225 is 15, which gives us the missing side of the triangle. So now, go ahead and find the value of sine theta, cosine theta, tangent theta, and then cosecant theta, secant theta, and cotangent theta. So using SOHCAHTOA, we know that sine is equal to the opposite side divided by the hypotenuse. So let's label all the 3 sides. 17 is the hypotenuse, 8 is the adjacent side, and opposite to theta is 15. So opposite over hypotenuse, this is going to be 15 divided by 17. So that is the value of sine theta. Now cosine theta is going to be equal to the adjacent side divided by the hypotenuse. So the adjacent side is 8, the hypotenuse is 17. So cosine theta is 8 over 17. Tangent, based on TOA, is going to be opposite over adjacent. So opposite is 15, adjacent is 8. Therefore tangent is going to be 15 divided by 8. Now cosecant is the reciprocal of sine. So if sine theta is 15 over 17, cosecant is going to be 17 over 15. Secant is the reciprocal of cosine. So if cosine is 8 over 17, secant is 17 over 8. You just got to flip it. And cotan is the reciprocal of tangent. So cotangent is going to be 8 over 15. Just flip this fraction.
Okay. So hope you see in the video. So, let's say in 20 seconds, Maria, can you tell us other video card?
Okay, thank you, Sam. So I want to thank you first for uploading us this video, because I learned much from it. First, the word trigonometry had a lot of words in it. As you were introduced to class, you told us about the keywords in trigonometry, whereby there was sine, cosine, and tangent. So I learned how to use a triangle that has even an angle theta to find the value of the cos, sine, and tangent, where we were given a formula that we can use to remember how to find those values.
Okay,
Thank
okay,
you.
Maria, thank you. Albert, can you tell us, like, in 10 seconds, perhaps what you pick from the video?
Thank you for your presentation. The first one, when I watched the video, I saw that the essay that I saw on the first slide that was introduced about trigonometry, and actually in the mind, as if I didn't got anything. I had sine, I had caught, I had turned, but when I watched the video, I came up with how these things come about. I learned about opposite. What is the opposite? The one that is opposite of the angle. The hypotenuse, being the side of the triangle which is the longest. Then the adjacent being the one that is the shortest. There I also learned how to use the three sides of a right-angled triangle by using a squared plus b squared is equal to c squared. And you come across and get the answer. And I also learned how to use the different side, the hypotenuse, the opposite, and sine, cos, and tan to find the different sides and how they are equal. Because as the video was ending, I came across that sine was equaling to 15 out of 17. There it could be easy to calculate and get the value of theta. Thank you.
Okay,
What
okay,
I picked from.
Okay, thank you so much. I think the video has it all, because if we look at slide number 1, which had the keywords where we had angles, sine, cosine, tangent, hypotenuse, unity circle, and then radians. So the video is giving us a review of what we are going to handle. So we can move on. We have angles as the first bit. So angles comprise or have quite a number of things. So angles are divided, or there are very many kind of angles. We have angles that are obtained on a straight line. We have angles. In that slide, we can see we have angles of different kinds. You can have 180. 180 is on a straight line, and if someone is given an angle or an unknown, and the angle is on a straight line, so it is very easy to calculate or to come up with the answer. So we have 90 degrees. There are very many degrees. So we have right-angled triangles, acute angles, obtuse angles, straight angles, reflex angles, whereby actually angles start from 0 degrees. Then we have acute angles. They range from 0 to 90 degrees. The right angle, it is approximately 90 degrees. Obtuse, it ranges from 90 degrees to 100, 180. Then we have straight angle. That is an angle on a straight line, summing up to 180. Then we have reflex angle. It is between 108 and 360. So there are very many kind of angles. We have full angle. Then we have acute angle, that is less than 90 degrees. Right angle, that is approximately 90. So there we go. So we have a small or a sample video trying to explain some of the angles and something.
Hi, welcome to Math Antics. We're continuing our series on geometry, and today we're going to learn about angles. In our last video, we learned about points and lines, and that's good because we're going to need lines to make angles. So let's start with a couple of lines that are in the same plane. We're only going to be dealing with two-dimensional geometry in this video. These lines are conveniently called line AB and line CD. Now, the important thing to notice about these two lines is that they're pointing in exactly the same direction. So even if we extend them forever, they would never cross or even get closer together. When two lines are arranged like this, we call them parallel. Now, you've probably heard the term parallel before, like parallel parking or a parallel universe or parallel bars. Okay, So parallel lines are lines that will never cross, even if they go on forever. But what if I take one of our lines and give it a little nudge? Now the lines aren't parallel anymore. In fact, they cross at this point right here. Let's name it point P. When lines cross at a point like this, we say that they intersect, and we call the point an intersection. And when lines intersect, they form angles. You can think of the angles as the spaces or shapes that are formed between the intersecting lines. These intersecting lines form 4 angles. 1, 2, 3, 4. But instead of calling them angle 1, 2, 3, and 4, in geometry, we name them by the points used to make them. For example, this angle here can be called angle DPB because if you trace along those points, like connect the dots, they outline that angle. And this angle here, we can call that angle APD because connecting those dots forms that angle. Now when naming angles, there's a nice shorthand that we can use. Instead of writing the word angle over and over again, we can just use the angle symbol instead, which looks like this. But there's an even simpler way to name angles. To learn that way, let's erase all the points and letters on our lines except for the intersection point and this one point here. Now let's imagine that the line segment between these 2 points can rotate around the point of intersection just like a clock hand rotates around the center of a clock. Let's also imagine that as we rotate the line segment, the point out at the end leaves a trail, like if a pencil was attached to it. The trail, or path, that's left when we rotate the line segment all the way around forms a circle. But if we...
Okay, so that is a brief introduction about angles and maybe to highlight about what the video had. Angles are formed from lines. So if the lines intersect, there we can form angles. But if at any point the lines are parallel, there we cannot obtain any angle. So angles are formed at the point of intersection. So we continue to the sine, cosine, and then the tangent. So we have the sine, as we saw, it has the opposite, has the hypotenuse, and then the base. So we are having the sine, then it is briefly, when you want to find the sine, it is opposite over the hypotenuse. Then we have the cosine, where it is equaling to the adjacent over the hypotenuse. Then we have the tangent, which is equaling to opposite over the adjacent. So if at any point I want to find an angle from any of these shapes, maybe they want the angle X. So if they want the sine, that is the formula for finding the sine. If they want the cos is also given. And at any point, if the tan is needed, we can also find the tan. And the other thing also, if the sides are also needed, we can find the sides. So we have the hypotenuse of a right angle. So we have this diagram. If I want to find side, any side, if at any point I'm given side A and B and they need C. So this is the formula that we can use. We have C is equal to the square root of A and then A squared plus B squared. So that is the formula that we generally use. Then we continue to, I have a small pre video, maybe I can play it for a moment and then we can see and continue.
What does trigonometry actually mean? In Greek, this red part means triangle and the blue part means measure. Trigonometry is one of the most feared topics in mathematics, but in reality, it is extremely simple. The meaning itself is so simple. It's just the measure of all the things possible in a triangle. That's all. Let's consider a triangle ABC. Let A be the length of the side opposite angle A, and similarly, let B and C be the lengths of the sides opposite angles B and C respectively. Take a close look at the triangle. What all can we measure in this triangle? We can measure the angles, angle A, angle B and angle C, or find the lengths of the sides, which in this case are A, B and C. These are the only 6 things we deal with in trigonometry. 3 sides and 3 angles. Out of these 6, we are given a few, and using trigonometry, we need to find the rest. It cannot be difficult. Actually, it gets a bit simpler as trigonometry generally
So that was the what? The video that had the what? The hypotenuse and then some other. Then we can continue to the unity circle. The unity circle. So the unity circle, it comprises of number of rotations. So we have different number of rotations beginning from 0. So it rotates up to 360 degrees. So that is the unity circle. Maybe a brief of the video.
Zero, pi over 6 and more. The next one to know is pi over 4. Then pi over 3 and pi over 2 are all of the radians I'll tell to you.
Horizontal circumference is pi times 2.
Oh, 30, 45, 60, 90. That's why I love unit circle trigonometry.
Oh, 30, 45, 60, 90. That's why I love unit circle trigonometry.
One more time. The x's are 1 square root of 3 over 2. Horizontal they must be. Square root of 2 over 2. And next are 1/2 and 0, the stately x.
Secretly there goes a that's coming next.
Oh, 30, 45, 60.
That is explaining more about the unity circle. So hope people were enjoying this lecture or this recording. So that is the unity circle. So as I said, it rotates from 0 to 360 degrees. Then lastly, we have the radians. Radians, those are also part of trigonometry. So if I can play a simple video here. Yeah.
In the previous video, we looked at how angles are measured using degrees. This angle would measure around 30 degrees. A right angle would measure 90 degrees, a straight line 180 degrees, and one complete rotation 360 degrees. Do you know why 360 degrees? It's somewhat arbitrary and had something to do with the base 60 number system. Do we have some other way in which we can measure angles such that it makes a little more sense? Yes, that brings us to the concept of radians, and trust me, not many people understand what radians mean. Most people know how to convert from degrees to radians and vice versa, but it ends there. To understand what radians mean, let's draw a circle. Let point O be its center and length R be its radius. Now let me take this length R and place it here at this point. Now all I do is push it onto the circumference of the circle. The length of this red part is still R, it has just become curved, and that's all. The curved length R starts from here and ends here. Now, from the center of the circle, we draw another radius that joins the other endpoint of the red curve. This length will also be r as it's the radius. Let's analyze the figure. We have an arc of length equal to the radius of the circle and two radii joining the center and the endpoints of that arc. Remember, the length of the arc is equal to the radius of the circle. This angle formed here is 1 radian. That's the concept of radians. Actually, there's radius everywhere around this angle. R, and that's probably why they call it radians. According to various scientists and mathematicians, this is a more logical way to measure angles. It's because we are measuring the angle in relation to the radius of the circle. But how are radians related to degrees? What would this angle be equal to in degrees? If you understood the concept of radians well, then understanding the conversion between degrees and radians would be a walk in the park. What is the circumference of a circle? It's 2 pi r, where r is the radius of the circle. We are talking about the circumference, which is the entire boundary of the circle. Now listen to the next question well. How many such arcs would you need to cover the entire boundary of the circle? Let me repeat the question. How many such arcs of length r would you need to cover the circumference of the circle? Pause the video and see if you can work through this on your own. The length of the arc is r and the circumference is 2 pi r. Yes, 2 pi r. It means we would need 2 pi.
Okay, so those are radians. So the computation, and if at all you're asked to, let's say, convert, because we can also convert degrees to radians and from radians to degrees. So that has it all. Maybe if there are any questions, welcome before we conclude, like in a minute.
Excuse me, sir.
Yes, please.
We request for a test.
That's always nice to hear. It seems you've grasped all the content.
Yeah, it was a very nice lecture that is easy to understand.
That's very good. Okay, thank you very much.
Thank you, sir.
For your contribution. It was such a nice gathering. So thank you very much. Bye-bye.
Thank you for your lecture.